Hello mga ka-wisdom! Welcome to Wisdom is Power channel. Kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos like this. Salamat! Today we're going to talk about three-phase short transmission lines. So for the short three-phase transmission lines, three-phase calculations are made in the same way as single-phase calculations because a three-phase unit can be regarded as consisting of three single-phase units, each transmitting one-third of the total power. The resistive and reactive drops are calculated as before. So for the power, that is the same equation, that is square root of 3 multiplied by the line-to-line voltage multiplied by the line-to-line current multiply by cosine theta, or simply square root of 3 multiply by line voltage multiply by line current multiply by the power factor. The same goes with power is equals to 3, but this time we're going to use the phase voltage and the phase current multiply by cosine theta. It is also equals to 3 multiplied by the phase voltage multiplied by the phase current and the power factor. So let's practice problem number 1. A three-phase, three-wire short transmission line has a resistance of 3 ohms and a reactance of 8 ohms per wire. At the receiving end, a balanced three-phase load draws a line current of 60 amperes at 13.5 kilovolts line to line, 0.90 power factor lagging. Determine the voltage at descending end. So we will write all the given first. The resistance is 3 ohms and the reactance is 8 ohms per wire. The line current is 60 amperes. The receiving voltage is 13.5 kilovolts and the power factor is 0.9. We are asked to solve the descending end voltage. So for our solution, we need to solve first the line to line, the base voltage, that is the receiving voltage, the line to line receiving voltage, all over square root of 3. So 13,500 volts divided by square root of 3, that will give us a phase voltage of 7,794.23 volts. So using our equation for the sending end voltage, that is I multiplied by the impedance plus the phase voltage, then substitute all the given values, that will give us the sending end voltage of 8,173.0958 volts. Multiplying this by square root of 3 to get the line-to-line voltage or the line-to-line sending end voltage. So that will give us 14.16 kilovolts. For practice problem number 3, an overhead three-phase transmission line delivers 5 megawatts at 22 kilovolts at 0.8 power factor lagging. The resistance and reactance of each conductor is 4 ohms and 6 ohms respectively. Calculate the sending end voltage, percentage regulation, and transmission efficiency. So again, susulat uli natin lahat ng given. The power is 5 megawatts. The power factor is 0.8 lagging. The resistance is 4 ohms. And the inductive reactance is 6 ohms. The receiving end voltage is 22 kilovolts. And the impedance is simply R plus X sub L or 4 plus J6 ohms. This is the per phase value. So we are asked to solve for the sending end voltage, the percentage regulation, and the transmission efficiency. So First, we will solve for the phase voltage. So line voltage divided by square root of 3. So that is 22,000 divided by square root of 3. This will give us 12,701.71 volts. So to solve for the phase current, that is power all over 3 multiplied by the phase voltage multiplied by the power factor. So substitute the values 5 megawatts all over 3 multiplied by the phase voltage of 12,701.71 multiplied by the power factor of 0.8, and this will give us 164.02 amperes. So this will be our line current, and using our complex form for the current, that will give us 164.02 multiplied by 0.8, the power factor, minus J 0.6. This will give us a current in complex form of 131.22 minus J 98.412. So using our equation to solve for descending end voltage, we just simply substitute all the given values. So this will give us the sending end voltage of 13,822.67 volts. So to get the line-to-line sending end voltage, we simply multiply this by square root of 3. So this will give us 23.94 kilovolts. So that is our answer for the sending end voltage. To solve for the voltage regulation or the percentage voltage regulation, that is the sending end voltage minus the receiving end voltage all over the receiving end voltage multiplied by 100%. So substituting all the values we computed, that is 23.94 volts minus 22 kilovolts all over 22 kilovolts, that this will give us 8.82% of percentage voltage regulation. And for transmission efficiency, we have to use our equation, the output power all over output power plus power losses multiplied by 100. So this will give us, first we need to compute for the line losses, that is equals to 3, because this is 3 phase, multiplied by I squared multiplied by the resistance. So that will give us 3 multiplied by the square of 164.02 multiplied by 4. The line losses will be 322.83 kilowatts. Then substitute to our equation for the transmission efficiency. The value of our transmission efficiency will be 93.93%. For practice problem number 3, a short 230 kilovolts transmission line has impedance of 5 angle 78 degrees ohms. The sending power is 100 megawatts at 230 kilovolts and 85% power factor. So what is the voltage at the other end? So again, we write all the given first. The power is 100 megawatts. The power factor is 0.85. The impedance is 5 angle 78 degrees. And the sending end voltage is 230 kilovolts. So we are asked to solve for the receiving end voltage. So to solve this, first we need to solve for the line-to-line sending current. That is power all over the square root of 3 multiplied by the line-to-line voltage multiplied by the sending power factor. Then that is 100 megawatts all over square root of 3 multiplied by 230 kilovolts multiplied by 0.85. This will give us 295.32 amperes. So, going back to our equation for descending end voltage, that is equals to I multiplied by impedance plus the receiving end voltage. So, rearranging our equation to solve for the receiving end voltage, the receiving end voltage will now be equals to the sending end voltage minus I multiplied by the impedance. So this will be our equation to solve for the receiving end voltage. So first, we need to solve for the phase voltage of the phase sending end voltage. That is the equals to line, the sending voltage and sending voltage all over square root of 3. And this will give us a value of 132.79 kilovolts. Then substitute to our equation for the receiving end voltage, that will be equals to 132.79 kilovolts minus the current of 295.34 angle negative 31.79 degrees multiplied by the impedance of 5 angle 78 degrees. This will give us the phase voltage of the receiving end. That is equals to 131.772 kilovolts. So, to solve for the line-to-line receiving end voltage, we just simply multiply it by square root of 3, and this will give us the value of 228.24 kilovolts. So, that's all mga ka-wisdom. So, again, kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment, at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos like this. Thank you.